Okay, hello everybody. So, using words, pictures, and formulas. A, explain how to parametrize an ellipse spanned by vectors v and w in Rn. B, we deleted. I should say I deleted. And then C is, how does the usual trigonometric parametrization of the unit circle, a special case of this formula, the one from part A. Okay, so first of all, remember, a curve, even if it's living inside some higher dimensional space, a curve is a one-dimensional object. And the reason we call it one-dimensional is because we can parametrize it as the image of a map from R1 to, let's say, we're going to R3. And if this purple curve here is the image of a map like this, then that means it's one-dimensional, because really all we needed was just this R1. We didn't need all three different variables. We could only just use one, like we could call it T. And okay, so this is going to be an example of that. This was not part of my answer. My answer begins A, with some words. Pick any two vectors, and I'll switch to formulas, v in Rn, and also choose another vector, we'll call it w in Rn. I'll go back to words. Actually, let's switch to pictures for a moment. I'll do pictures in sort of a blue color. Let's imagine we're in three-dimensional space. Then let's just picture these vectors. Maybe v is right here, going out from the origin to this point. And maybe w is over here, right there at that point. Or I can view it as a vector from the origin. That's w, that's v. Okay, so there's our picture. We're just visualizing these two vectors. Now, define a map from R1 from R1 into Rn as, and how do we define this map? Now I'll switch to the formulas color. Well, okay, so maybe let's put the input space, the output space, and let's take a real number t and send it to what? Well, here's the formula. The cosine of t, it's just one real number, but we need a vector. So actually, I'm going to use cosine of t, this real number, as just a scalar, and I'm going to put the components of my vector v that I chose. I chose some vector v, here it is. Then I'm going to use my vector w. And how am I going to use it? I'm going to use a piece of it, only sine t of it. And then this gives a map, This is a map. So let's give it a name. Let's call it F. Okay. Great. Now, what I'll say in words now, remember we need words, pictures, and formulas, is that the image of this map, is a curve that we might call the ellipse through v and w. Okay, and I'll go back to my picture over here, and I'll try to draw some part of that ellipse. Maybe it goes I don't know what it does. It's hard to draw in 3 dimensions, but I'll do my best. Maybe it looks like that. So in particular, this ellipse goes through v, it goes through w, and then it keeps going, and eventually it gets to actually minus v, which is over here, and then it keeps going, and then eventually it gets to minus w, which is that vector way over there. And then it just keeps going, and it just loops around and around and around and around in, sort of a circular shape, except if w is way longer than v, then it won't be circular. And also, v and w don't need to have a 90-degree angle. They could just be any two vectors. And you can just do this and see what happens. Now it might degenerate if they're if v and w are in the same line. That would be interesting to think about what happens then. You could try it in GeoGebra, for example. Okay, so did I explain how to parameterize the ellipse? Yeah, I think so. Yeah. Maybe I'll just add something. It's easier to see /draw in R2, especially if v and w are sort of simpler. If v and let's take v to be 3, 0. Having a 0 is gonna make it simpler to draw. Let's take this to be 0, 2. Then a little picture that I'll have is, let's say that's the point 0, 2, and then maybe this is the point 3, 0. Then my ellipse is just going to be like this. Yeah. Okay, now that's pretty good. I think I did part A quite well. Let's look at part C. How is the usual trig parametrization of the unit circle a special case of this formula? So first of all, you have to know what the unit circle is. And so let's go down. And you have to sort of already know what I mean by it. What is a trigonometric parametrization? Well, when you think unit circle, think theta goes to cos theta, sine theta. And, this is the unit circle because every single point here has length 1 from origin. Right? Because cos squared plus sine squared is 1, the square root of 1 is 1. So this is a special case, of our formula above, since we can take or pick or choose or something, pick what? And I'll switch to formulas. V equals 1, 0. This is also called I hat. This is also called E1, etc., etc., etc. And I can pick W 0, 1, which is also called J hat, which is also called E2, depending on what you prefer to call it. But anyway, these are very simple vectors. And then, our formula becomes T goes to cos T times V plus sine T times W, which would be cos T times 1, 0 plus sine T times the vector W, which is 0, 1. And now I can just, linearly combine these things, and I get a cos T plus a 0 sine T. So 1 times cos T plus a 0 times sine T. Maybe I'm doing too much detail there. I think you can, sometimes eliminating detail is easier. Just look at the tops. You're clearly going to get nothing here, 0 there, and a cos T there. And now, what goes in the bottom? Well, you're clearly going to get a 0 there, plus a sine there. And as you can tell, these are the same, except for I called the variable t here, and I called the variable theta there. They are the exact same, right? The image of these maps are identical. Yeah. That's it. Okay. All right, I was quizzing myself. What you should do is pause the video, go back to the beginning, where it's just showing the question, and see how much of this can you remember. Can you do the words, the pictures, the formulas yourself? And maybe explain it differently. Do it in a different way. For example, I was quizzing myself. Here's my slightly different explanation. Here's part A. Interesting. I gave some more details, especially here. See, I said that f of pi over 4, we say f of, or f applied to pi over 4, is this specific vector right here, which took some time for me to actually compute. Like I had to know the cosine of pi over 4, etc. And then f of minus pi is over here. It's at minus v. And, f of pi over 2, I think, would have been this point right here. F applied to f of t, where t is going to be substituted in with pi over 2, and that gives me that point. Okay? And then here is my